and answers. And I think that these Q&A can be for the estimation of dietary intake sessions, as well as any other questions that we have from previous sessions. So this could be a very open question and answer time period. So with that, I will hand it back over to Dr. Caldas to pick up where she left off yesterday. Thank you.
Thank you, Jason. Good morning, everyone. Let's start our last part of our marathon this week. Yesterday, we finished with this slide and also showed you the IEDI template for chronic dietary assessment conducted by the GMPR, which shows that you have to do to estimate the intake and characterize the risk for each one of those cluster diets. But today is not so complicated because you have that template. All you have to do is just to put in the numbers, the STMR values that were estimated by the meeting. Sometimes I want to point out some things. In the chronic assessment, you should have all the diet over there. So when a compound comes with only requesting with data only for additional crops, so we have to do all we have to estimate the dietary intake with all the previous recommendations. So this will be very different from the acute exposure. So just remembering that when we report I'm going to show you later where it's going to be reported, but this should include all the STMR recommendation done up to that time by the GMPR, not only the recommendations made at that GMPR where we conduct the study. So maybe this will be more clear later. So that was acute, long exposure, chronic exposure. That means lifespan exposure. Yes, from the time the child start eating fruits and vegetables until the end of their lives. But then now we have also to conduct acute dietary exposure and risk assessment. This acute, before it was just in 1997 when I had my first GMPR meeting, that this whole issue of acute exposure came out. In 1997, there was a workshop during that year. Of course, I did not participate because I was just joining the group. There was a workshop to discuss the possibility of adverse effects coming from the acute exposure to pesticide through food consumption. What happened that really led to that concern was that in 1996 or something around that time, in UK, there was a case where there was a misuse of organophosphate pesticides in, if I recall well, in melons in UK. So what happened is that people who consumed that melon really got sick because the application was just too high. It was overwhelmed. The residues were very high and people just got sick. Because until then, there was no acute concern regarding pesticides, because as we normally think about everything that goes in the diet, we are more concerned about chronic exposure because we eat every day, because we eat more or less every day, and they think the food is more or less, has more or less residues or contaminant levels every day. But after that event, so it became clear that we should think about it, about potential adverse effects from acute exposure, mainly for those compounds who are really acute toxic, like the organophosphates, the carbonates. There are some compounds that are really pyrethroids. They really can cause acute adverse effects, which was seen, for example, in farmers. Intoxication with organophosphate compounds was very common. Still is, organophosphate compound is involved in most of the occupational intoxication case around the world. So there was a workshop and they thought about it and they put together some equations, and that was in 1997. So we start actually, but at that time, there was no acute reference dose. There was just a toxicological safe parameter for chronic exposure. So just after it was decided that we should be concerned also about the dietary acute exposure to pesticides, so the WHO group thinking that they should also establish a safe acute exposure toxicological parameter, and that is called acute reference dose. Just to remember that, just to point out that in US they call everything reference dose, but here in the rest of the world it's ADI for chronic exposure and acute reference dose for acute exposure. So, and the first acute reference dose were established by the FAO group within the GMPR in 1999, and we start applying the equations that were first derived in 1997 in 2001. So there, as you can see in the report, 2001 report, if I'm not mistaken, 2001, I should have confirmed that this morning before I tell you, but it was in the beginning of this century. The first acute reference dose for sure was in 99, and then we need the acute reference dose to proceed in the acute dietary exposure risk assessment. And then we, in 2003, we actually, during that period, the key point of that equation was this value here, the variability factor. And at that time, we had no data at all to estimate what would be this variability factor. So there was some guess, yeah. The variability factor should be 5, 7. Those of you who go to CCPR, you've heard about those variability factors, 5, 7, even 10. It wasn't until 2003, actually, that we decide in this final equation where a variability factor, a single variability factor was defined. And this was confirmed later on during the meetings. So I like this picture here of this child eating this big watermelon, because this really illustrates an acute exposure. 1.5, 2 years old child eating a large portion of watermelon. So that's what the acute exposure reflects. It's higher exposure, which again, I explained that early, happens, it does not happen every day, but sporadically you could have a peak of exposure to pesticide through food consumption. And that peak may, in some case, depending on the peak, lead to adverse effects. So when we conduct dietary risk assessment, it's actually what we want to prevent: chronic or acute exposure. We want to prevent any adverse effect. So the equation, the name of the equation is that one, the equations, because there are four. International estimated short-term intake. As I mentioned before, the word short-term and acute, they kind of go back and forth in the GMPR as well. But here the equation, the name is really short-term. And when we define that equation, there are some aspects of the crop that needs, and of the pesticide application that needs to be considered. First is the size of the crop. So we've been talking about reducing crops in the field. So we talk about small crops, big crops. So watermelon, for sure, it's a crop that has a high unit weight. But for example, grains, yes, if you think about one grain, one single grain, that's small, oil seeds. So you could have, actually, they are very small. And you have apple, which is a very, which is a small crop as well. It has low unit weight. So you see here the first parameter that is used in the equation, the unit weight. And the second parameter that is used in the equation is the large portion. Remember that for chronic, we use normally the mean consumption. Even when you do probabilistic methods, that's what we do here in the lab, we use the usual mean consumption, even for probabilistic methods. But here for acute exposure, we are not concerned about the mean consumption. We are concerned about that day when someone decides spend the whole day eating only watermelon or eating only apples. So in a population, you have a distribution of consumption, and we are concerned about what we call high consumers. Can someone turn off the microphone, please? So here for acute exposure, we are concerned about people who are high consumers of a food, at least in some days of that food. So, and it was defined back then that a large portion would be defined as the 97.5 percentile of consumption distribution in the population. The 97, I'm not sure how much familiar people here are with the percentile distribution, but imagine if you have a database of food consumption by a population. So you have people who eat very low, and you have people who eat at the average, and you have people who eat a lot of that food. And this maybe is different for each different food. And we are concerned here with the people who consume a lot of that food, but not the highest consumption level, but the 97.5 percentile of the consumption distribution. That means that 97.5% of the population consume less than that value, and 2.5% of that population consume a value which is higher than that value. So that's the large portion. Here, the HR, you know what it is, the body weight is the body weight of that population. I'm going to talk about the parameters first, then we go back to each equation in each case. So we talk about the unit weight, which is completely new. The consumption number is the large portion. The HR was derived from the supervised trials. The body weight is the body weight of the population. And another, as I mentioned, another very key information here is the variability factor. The variability factor shows how much. So let's say you go to the supermarket and there is in a place there where you have a bunch of apples. Supposing that all that apple came from the same lot, that means that apple came from the same farmer. Yes, this does not happen normally. Sometimes it does. Sometimes the supermarket or the grocery store buy apples from different farmers and put them together to sell it. But this was really designed to a case where all the apples that are exposed to be bought came from one single farm. That means that came from all the apples belong to a single lot. So every apple in that population of apple, every apple unit in that population may have, and they do have, a different residue level. So if you are going to analyze each apple separately, you may find different residues in each apple unit. Why this is very normal? Because sometimes even in one single orchard, you have the farmer who applied the pesticide. Let's see if it's applied foliar application, and some apples are kind of hidden behind the trees, the leaves, sorry. Some apples are more exposed to the application, to the spray. So you're gonna have different varieties. So not all the apples within that orchard, within that lot, was exposed to the same level of pesticides during the spray, the foliar spray. So it is normal that every single apple could have a different residues. By saying that, so in the supervised trial, so the sample is collected at the PHI, for example, not all the sample for the orchard, of course. You collect a number of units, yes, to give, we talk about that, a good sample, not very few units, but a good sample, a few units of apple, which will give at least 1 kilo of apple. Bring to the laboratory to be analyzed. In the laboratory, all the apples are put together, and then we take a portion of, we homogenize it, and we take a portion of that to analyze, of the homogenized apple lot to analyze. So the HR and the STMR that are the values that we derived when we evaluate the residue trials reflect the levels, the median, and the highest level within that residue data in a composite sample made of many apples. But in the acute exposure, so this is very good to estimate the STMR for that, the median for chronic exposure. But for acute exposure, you are thinking about, you are thinking about a very special situation where you eat a lot of apple or watermelon, and by chance, that watermelon that you eat or that apple that you eat has the highest residue within that lot of apple units. So the HR that you have derived from the residue trials does not reflect, it does reflect the highest residues from the analysis of composite samples, but does not necessarily reflect the residues with what we call the hot apple. The hot apple. That means that apple that has a highest residue of that single pesticide. So that's what the variability factor accounts for. It's really to estimate from a highest residue coming from a composite sample to a highest residues from the highest residues coming from composite sample to a residue found in the single apple. Let's keep here with the apple, but could be as well the watermelon in that lot. And this variability factor is the one that before there was no data to show you how much would be that variability, how much we should multiply the highest residues taken, which was estimated, analyzed in a composite sample, what would be the number that you should multiply to estimate what would be the residue concentration of the unit of that lot which contained the highest residue. So this number at the beginning was 5, 7 in some cases, even 10 in some cases. Because in the beginning, back in 1997, we did not have any data to really show what that variability factor would be. Okay, by explaining everything, all the parameters of these equations, why we have different equations. The first equation is what we call case 1. It's for meat. It's used for meat. In this case, the unit weight is lower than 25 grams, so it goes to meat. Now I'm not sure if this meat is correct. I think there is something wrong here. No, it goes to meat and also to grains, oil seeds, legumes like peas and beans, fresh peas and fresh beans that are treated post-harvest. Actually, they should have started naming those equations starting from case 3, because those greens, oil seed and legumes treated pre-harvest are in case 3. In case 1, what is important here is the large portion multiplied by the HR, or in some case HRP, when for meat and also for small crops, grains, very small crops, when they are treated post-harvest. So like in grains in a silo, yes? So the grains in a silo, you would consider them, you'd consider that in that silo, you should use the residues that in which the grains were treated post-harvest. The residues reflect actually what was applied for post-harvest treatment. This is the case when you use HR for meat and also for those small, very small crops, but that were treated post-harvest. I'm going to jump from case 1 to case 3 here, just to compare those two, because case 3 is for milk, eggs, and all those grains, milk and eggs. Why milk and eggs? Because normally the milk that you buy is blended. And the eggs, that means that comes from different milk producers, different farmers. And in most cases, eggs as well comes from different farmers. So it's very hard to determine which HR you're going to use, because you could have a milk that came from a farm where, I don't know, the cow was highly exposed to pesticide through feed consumption, but also mixed with milk that came from a farm where the cows were not so exposed, were exposed to a much lower level from feed consumption. So, and then what you have in the supermarket, what you're going to really drink, unless you drink directly from the cow, from your own farm, will be a mix, yes, a blended of milk coming from different sources. And that is the same for eggs, and that is the same for grains, oil seeds, those small crops where the application was pre-harvest. So in this case, you use, instead of HR, you use STMR. So the STMR is normally used for processed food and for mixed blended food. And the HR, with a very few exceptions, for example, where you have a sample that was processed post-harvest. Just a minute. I have people here talking very loud. Just a minute. Sorry, people were talking too loud here. In this case, so for our processed commodities, you use STMRP, and for blended food, you also use STMRP, unless here you have a processed commodity that came from a crop, for example, grains that were treated post-harvest. That means that you did not blend them after they were treated. The blend was done before treatment. So this is case 1 and case 3. And then you have this case 2 that is divided by case 2A and case 2B. That's where, so neither here or here, you will apply the variability factor. Because in both cases, you are talking, in this case, you are talking either for small grains, small unit weight, grains and pulses and legumes, or processed food. Case 2 is where you should consider applying the variability factor. So case 2A is the apple case. Case 2B is the watermelon case. Sorry. So in case 2A is the apple case, where your large portion is that is high consumers of apple eats more than one apple. So the unit weight, let's say one apple weighs 100 grams, but I can consume in one day the 97.5 percentile of consumption of, I am a high apple consumer. So that means that my unit weight is lower than my large portion. That means that I consume more than one apple. If the unit weight of an apple is 100 and I consume 3 apples, then I have a large portion who is higher than I consume a large portion that is higher than 100 grams, which is the unit weight of one apple. In this case, you have to, you look at the basic equation is the same. Consumption, residue concentration times consumption divided by the body weight. Here you have the unit weight, because here you are assuming the first portion of the equation that among the 3 apples that you may consume, one of those apples contain the highest level of residues within that lot. So it assumes that in that lot that has many apples, has at least one apple that has the highest residue compared to all the residues found in each apple, and you're going to eat that day. So the amount of apple that you consume here is that hot apple, okay, times the highest residue in the highest residues coming from the residue trial, times the variability factor. Because here again, you are using the highest residues reflect the residues in a composite sample, times the 100 gram, which is the unit weight of one single apple, times the variability factor, because you have to think that that first apple that you eat has the highest concentration, so you have to multiply the residues in the composite sample times this variability factor. But then every single apple that you consume after that does not have that such higher level of residues. So the next portion, imagine that you consume 3 apples. The first one is the hot apple, and you multiply the residue times the variability factor. But the last 2, they're not hot apples anymore, so you don't have to multiply the residue times the variability factor. So if one apple is 100 grams, the large portion is composed by 3 apples. Here is 100 grams, and here is 300 minus 100, because that's the 2 apples that are left for you to consume that day. And the variability factor, I'm going to explain the next slide more closely, is adopted. It was adopted in 2003 as 3. We're going to talk about a little bit more about variability factor in the next slides. In case 2B is the case where the unit weight is larger than the large portion. That's the case of the watermelon. Normally, we don't consume a whole watermelon. A watermelon can weigh 2 kilos, but you don't consume all of it. You just consume part of it. So you just have to multiply the large portion, which is the portion of the watermelon that you consume, times the HR, times the variability factor, because you also have to apply that to that residue, the composite sample, you have also to apply the variability factor. And in our case, you have to divide by the body weight. So I hope this is clear, more or less, because I think maybe I got confused here to explain, because there are too many details, but basically that's it. Normally nowadays, you don't have to think much about it, because the template knows exactly which equations should be applied, which number should be used, if it's AHR and or STMR, unless you have the detailed information that is post-harvest or pre-harvest, because then for post-harvest, for grain, you use equation case 1, and for post-harvest, for pre-harvest for grain, you use case 3. So then again, a little bit talking about the variability factor. I think we explained that. Here's just a picture of my ex-PhD students, Andrea, who during her master project, she participated in an international project conducted by Arpad Abrush, which is who is a former member of GMPR, and he coordinated a project, international project from the Atomic Energy Agency, where trials were conducted in many countries with many crops to really determine and confirm that the variability factor of 3 should be adopted, because this was adopted in 2003 by after a paper published by Dennis Hamilton and Arpad Abrush. Dennis Hamilton just left us 2 weeks ago, unfortunately. But this paper of him and Arpad and other authors, they collect data that was available in the literature and have reached the conclusion that the variability factor of 3 would really cover all crops and all pesticides. But then at that time, there was no really data which was designed to really confirm that. So that's what Arpad coordinated that study. We did that in Brazil with papaya, mango, and eggplants. And we did that with organophosphates, some organophosphates, different organophosphates, and it was very clear that a variability factor of 3 is a good estimation. And you see that Andrea here is collecting 1 mango. And nearby Brasilia here, in a commercial farm, all the studies were conducted in commercial farms. And we had to collect at least 120 units to really determine with a good confidence level the variability among the analysis of each of the residue, the variability of the residues from the analysis of each mango. So we analyzed in the laboratory 120 mangoes, and then a lower number of from the control plots. So this is the data from the variability factor. The concentration data in the equation comes from the residue trials, yeah, HER and STMR. And the large portion, the unit weight and the body weight, comes from individual countries, because the cluster diet, it gives you, it's not really a consumption information that is given by the cluster diet. It's really the amount of food that is available for consumption within a country. And it's only the mean. But here, to estimate the acute exposure, we need real consumption data. There are many methods to collect consumption data. So you have a diary, you have a 24 hours recall. Different countries use different methods to collect real consumption data, because it has to be clear. Maybe I did not emphasize that the cluster diet, it's not real consumption data. It really only reflects the availability of food, the amount of food available to be consumed by the population. But here we need real consumption data. That's why I keep saying that, and we have been having consumption data for acute exposure assessment for some countries since the beginning, 2003. And at the beginning were different countries, European countries, but now they use the Primo template, which is a template, a database that includes consumption data for many European countries. Here specifically Belgium, those countries here. So 13 European countries are included in the PRIMO. Maybe some of you know this European database for consumption data. It is really real consumption data, how much a person consumes every day. Normally you have 2 different days, 2 different 24 hours recall, or 2 different days report. And you have data from Australia, from Canada, from China, from Japan, Thailand, and the US. Since 2000, maybe 14, I myself provided consumption data, Brazilian consumption data. And here in Brazil, the consumption data, which is collected by the IBGE, which is the Brazilian Statistical Institute, that collects consumption data in Brazil since 2003. And I use this consumption data, Brazilian consumption data, to conduct dietary risk assessment here in my laboratory, a published paper, research paper. And this year already I provide to Trinji, which is the person from the Netherlands responsible for putting together all this data in the ISTI template. I provide Trinji already with the most updated consumption data from Brazil, which were collected in 2017 and 2018. So this data, Brazilian data, could not be used at this GMPR because I provided a month before the GMPR this year, but it will be used starting from next year. So we kind of have a good representation of the world here. We don't have any consumption data from other Latin America except Brazil. So the countries should, and some countries here in the Latin America, they do collect consumption data. I know that Colombia, I think, have real consumption data that they can provide. And the thing is that they should provide the large portion, the 97.5 percentile, not the mean. And they should provide also the unit weight and the body weight of the population. But those of you from other Latin American countries should think seriously to send WHO the consumption data to be included in the data set for acute exposure. And normally we have to provide unit weight and body weight as well. So now, before we move, I'm going to show you the template. So let's open. Oops. Wait, because I'd like to open from the beginning, because then you can see it. It's updated 2021. Oh, it was open already, sorry. Maybe I should close it then. Sorry, I'm confused here. Right. Where is that? It's telling me that it's open already, but I don't see it. Let's try it again. Okay. And then we have to habilitate the macro. Can you all see the template? Please, someone tell me if you can see the template. Yes. Okay, here is just the ISTI template, acute exposure. And then there is some, some explanations here about the template and how it should be used. Just there is a manual, which I normally don't like it. It was updated on October 2020, so it's the last updated version. As you can see, it's the 21st version of the template already. So sometimes we have more than one version in 1 year. And then you have here the data. So basically what you have to do, it's what we did for the IDI template. So you put the name of the compound in capital letter. I'm going to put Maria here now because we're going to make up numbers here. Number of compound 154. The acute reference dose 0.1. Yes, totally aleatory. And then the order here is the same order as the codex. And here you also have for groups here.
Hello,
but normally,
sorry,
yes?
you're seeing your Excel description table, not the actual the actual.
Oh, you don't see?
No,
You don't
just
see my Excel template? No?
no.
Right now, no,
Oh,
no. The
What
screen
do
is
you-
black.
oh,
Well,
the screen is black.
I see the initial page.
I see the spreadsheet, but in the manual
The manual.
tag.
Oh, yes? What about
Yes.
now? Abbreviations?
Yes, the manual tag is what I see right now.
Me too.
Okay. What I'm going to do is start all over. Let's start over.
Open it with the IST calculation open tag.
Yeah, that's it. Can you see it now?
Not. No, it's the same.
Yes, the manual and
The
now.
manual.
Yeah, the manual we're actually seeing.
Now, fine.
Okay, okay.
It's
I don't
right
know
now.
what happened. Okay, good. And I just put aleatory name and aleatory number and aleatory acute reference dose here. You just have to remember to put the name in capital letters. And here there is the template. And here, as I mentioned, you have to enter, although there are the groups here and subgroups, you have to enter the name, the numbers, the STMR, NH, and HR. I think I mentioned back there when we were talking about crop grouping, although you make a recommendation for crop grouping, an MRL recommendation for crop grouping, and a STMR for that group, which is relevant for the chronic intake. Here, you need the numbers, the HR mainly for specific crops within that group. So that's why when you look at the reports, you're going to see exactly that. So when you have recommendation for the whole group, you actually make an estimation of HR for each crop of that group. And then you enter here. Yeah, let's see. Although the template here, let's see what the template has. It has the STMR, the HR, because you saw you may use one or the other one. You have country. You have the consumption data, which is here, but here you have the country who provide the consumption data. So for one crop, you may have data from different countries. For example, for lemon, you have data from Primo, which basically is the European countries, but here it says exactly from the Primo data set, it's consumption data from DMARC, because here, what Trinity did, she already took from the Primo Primo data, which is European database, the highest consumption number, because that's what the acute exposure will do here. Although there are data entered from different countries, what the template will do will estimate the intake from the highest consumption figure, because the residue is the same, but it will take the highest intake for adults and for children. And there is something here also that we have to explain. Here, the final template, it will give you different results for adults and for children. And also make a different table for women. Why? Because there are some compounds, for example, triazoles, which can cause adverse effects to the fetus. So for these compounds, there is an acute reference dose separated for women. So this final table here, it's only for that subpopulation, and not all countries have specific information for that. Actually, in Brazil, we know actually if we have specific data for women. And so in that case, when you know that the compound may cause an adverse effect to the fetus, and there is a different acute reference dose established for that subpopulation, you should make a final table for women. And you should actually complete a different template for women. So that is for that, because you may see that is different. So in women, they may consume different portions of food during pregnancy. And when we say women, it's not all the women, it's women normally from 12 to 45 years. Women, what we call women of childbearing age, which so it's just this phase of women where she can bear a child. But here we're going to do just a final table for adults and children. You're going to see that there will be an outcome for children and for adults. For not for adults, but for the general population. Here it's not quite right, because it will generate intake for the general population, which includes everybody, and a different outcome for children. And you see, for example, the data which was generated in Brazil, we only have consumption data for those who are 10 years old, 10 years or older. We here in Brazil, we don't have consumption data at national level for children. So the data that are provided, it does not apply to children, only for people 10 years or 10 years old or higher. So here there is the country and the population. Here, let's see what talks about Brazil here. I think here, data from Brazil, general population higher than 10 years, because here it really gives you number of people, for example, in case of lemon, here number of people who reported consumption of lemon in the Brazilian database. Because normally, if the number of people who report consumption data is very low, actually we don't use it. Yes, it was decided that you cannot estimate a 97.5 percentile when the number of people who really report consuming a certain crop, it's not reliable. Here you can see the difference for lemon. In Brazil, it's 69 grams per person. And in where is it? In Europe, Denmark, it's much more. So when the template will calculate the estimate, will pick the consumption from Denmark, not from Brazil, or not from Japan, or not from other country, because in our cases here, the consumption figure is lower than the consumption for the consumption in, excuse me, my nose is running today, for Denmark. Denmark really has the highest consumption, large portion for lemon. So, but the program will do that by itself. The same for lime, the same for other crops. And here we have data for our population groups. Oh, and also the country has to provide the unit weight. For example, I provide that in Brazil, a lemon weighs 23 grams, but in Denmark is 71 grams. In, I don't know, in other countries here, it was not reported, so only you have these 3 reports of unit weight. The variability factor is the same for everyone. The case is two-way. Yes, lemon is two-way, the case. And then you have the same data, not for Brazil, of course, because I told you that Brazil, we don't have data for children 1 to 6 years old. We only have data from 10 years higher. So we have consumption data from, although here it's written 8 months to 16, but normally it's children much lower. And here you have the same information, but for children. Yes. And it's case 2. Yes, lemon is case 2 and everything. And then you gave the template the reference dose, so it will calculate the percentage of the reference dose. And that goes for everything. That goes for everything. Let's fill out some numbers here. So you should all fill up the numbers here in this WC actually. So or here is it, if you have for the subgroups, and here it will actually, in the past actually, I should correct myself here, because now this last version of the template, it will, let's put a number here. And even though I know that for Mandarin, we should use case 2, and case 2 use HR, you should enter here both STMR and HR. So 0.2, let's see, as it's STMR, and 0.7 as HR. So what's going to do, it's going to transfer this HR for every single crop. If you look here, it will go transfer here, and it will use the STMR for processed commodity. See, I put here the STMR and the HR. It will repeat the HR here, but repeat the STMR for processed commodities. Juice, because it will use STMR for processed commodities. So we do the same here for orange, I don't know, 0.5 and 1.5 for orange. So it will be the same. It will repeat the same number here, and we'll use the STMR for baby food, jam, canned baby foods, and any unspecified food processed from orange. And then we can go further a little bit for apple. Let's go to the grain, because there you have kind of to decide stone. Let's do a stone here. 1 and 2. See? Even for dried cherries, it does not have processing factor, so it just repeat what was given before. If you do have a factor and it uses a default processing factor of 3, if you do have a real value and a real processing factor, you can replace that number here. But this is a default number. And you see here that for processed commodities, it uses case 3. So it knows already which case it should use. You don't have to worry about it. You just have to enter both number, STMR and HR. It will fill out the rest of it. And that goes. Let's not spend too much time in here so we can finish before break the theory about it. Let's see. I want to, blueberry and bushberries. They are very small, right? Let's see. And raspberries, for example. Let's put 0.1, 0.5 as the highest value. See? No, I did not 0.1. It seems that I put 2.1. Let me start all over again. It doesn't make sense. STMR is always lower than HR. 0.1 is 0.5. Okay, now it's correct. So it's case 1. It's case 1 because it's a small, has a raspberry, it's a small fruit. So you apply HRs. I did not put in that slide, but those small fruits you apply. You don't have variability factor for those very small fruits. So you apply case 1. And then it already calculates for each one the percent of the acute reference dose. You see? It already has those values there. And case 3 for processed commodities, which uses STMR. What I want to do here, it's an example for, so all those berries is case 1, except, because they are very small, except for elderberries and grapes. Why? I may explain, because for those, you have a bunch of grape. You don't use one grape like that. So your large portion is made of a bunch. So it's one bunch of grape. The unit is one bunch of grape. It's not one grape for grape in this case. So it's case 2B. Because normally the large portion given by it's no more than one bunch of grape, which weights, look here, where is it? In Canada, one unit of a bunch of grape it's half a kilo. It's a huge bunch of grape like that. So in the large portion, it's less than that unit weight. That's why you use case 2B, not case 2A. So normally, I can use a bunch of grapes, but the unit weight of a bunch of grapes in the countries which provide the data, it's a huge bunch of grapes. So you eat a portion of that unit weight, so it's case 2B. So let's put a number here for grape. Let's put, I don't know, 0.3 and 1, just for fun here. And if you don't have any data on processing, and it just estimates, assume that for juice, the STMR is the same as the STMR in the fruit. But if you do have processing factor and a real STMR for juice, you can come here and replace it. This is just a default. But if you do have real numbers, you just replace for the real numbers. Okay, let's go, because actually what I want to do here is just to see how it works and And then you have all crops there, following the codex classification. The order is the same as the chronic template. I want to show here the grains. Broad beans, it could be for the pulses as well, but I think the grains, it's more common to be used post-harvest treatment of the grains in the silos here. Here, the rye, quinoa, yeah, rye, it used as a default, okay, case 3, because it assumes that is pre-harvest. So it's case 3, it used the STMR. But you can change it here. Change to case 1 for post-harvest. You can just change it here if you want to, case 1. If it is the quinoa, the rye, the wheat, the maize was treated post-harvest, you just change the rate here. And then, and if it's pre-harvest, normally you don't even have actually, where are you going to put here? Okay, let's 0.04. And if it's pre-harvest, you don't even have the HR. You don't have HR for pre-harvest. If for grains, you don't establish HR if it's pre-harvest. You only establish STMR for pre-harvest application to grains. But if you can choose, you can change here. See how can we change? Case 1, if it's post-harvest, see? And then you have to enter the 0.4 and an HR for this post-harvest treatment, let's say 1. Okay, this is the same for, see, when you change it here, it change it here immediately. Here it did not use the STMR because it did not have any processed commodity for quinoa. But let's try high. Let's change the case here also, just to be different. And for high, there are a lot of processed commodities, bread, grain. So let's put 0.51 here. See, it used the STMR for processed commodities and the HR for rye, because it's post-harvest. If it was pre-harvest, would be case 3, STMR. You don't even estimate HR for pre-harvest treatment for grain. I think we can use some more, but that's basically it, the main points for this template. And then you ask it to make the final table for adults and children. So you press here and wait. The calculation is ready, and this is the outcome. Okay, so compound Maria, here it doesn't have that bug, so it is written here the acute reference dose, and then you have all the crops for which you enter the value. It has all the values that you entered, and let's see what we look for. Here it gives the intake. It ranges from 0.04 to 3624. And what we are looking for here is the maximum value, right? Because that's what it's important to us. The intake, the intake range from different countries. You see the variability of the intakes because you have data from many countries. And the percent of the acute reference dose. And it gives here for everyone, that includes children and the general population, the highest value from here gives you already, if there is a health concern, was 90%. Which crop? Orange. 90% of the acute reference dose. That's the main difference between the acute and the chronic. The chronic is the whole diet. The acute, you have a percent of the acute reference dose by this approach, of course. You have the percent of the acute reference dose for each single crop. And then you have for everyone, general population plus children, the highest value was 90% for orange. And for the general population only was for orange as well, but it reached 50%. And this 90%, the highest, came for children. And that's what happened in most of the cases. Here, it did not exceed the acute reference dose, but I'm going to give you some examples where there was an exceedance, and in most cases are for children. So when we find an exceedance of the acute reference dose for some crops, is for children. Why? Because the consumption, the food consumption for children relate to the body weight. It's higher than for adults. And we had some weird numbers of consumption by children. I remember many years ago, we used to laugh because France had reported, I think 100 milliliters of wine for children, or more actually. And we had some weird figures, like one child could eat 800 grams of spinach. And I think the countries are, after they submit the data, they have to evaluate critically, before they submit the data actually, they should evaluate critically if those numbers are really correct. Because if you have a very high and probably not real consumption figure, you're going to have a very high intake, and it will have an impact on the MRL setting. So you could, let's see here, the intakes. The large portion, which actually gave to the highest residue here, was for children. Look, 800 grams of orange in one day for children. And that consider everything, consider the juice, the jams, put everything together, and consider as well, because here we use the default, that the residues in the juice are the same residues in the fruit. And it assumes as well, yes, it assumes that there were no dilution of the residue. So it just assumed that everything, the orange, and here I did not get into that detail, but you have to see if the STMR and the HR that included there was in the whole fruit or in the pulp, because hopefully here, I don't know, because there was a completely aleatoric number. That's why it's important for fruits to have residue information on the pulp, because here you have a very high number for consumption. And if on the top of it, if you also have an overestimated level for orange, which has residue in orange, which has an inedible peel, you're going to have an overestimation of the intake and consequently an overestimate of the percent of the acute reference dose. So that's why I say that the numbers that comes out here are as good as the numbers that you put in. And here I would say that this consumption figure in China is very huge. For cherries, the highest consumption figure came from Denmark, DK, I think it's Denmark. Denmark, I don't know which country is this. Maybe someone can tell me. China, Finland here. Brazil normally does not come up with a very large number, so it's very rarely is selected here because we have to select the highest figure because it's the worst situation. For this compound, there was no exceedance. So if you have questions, I can explain in more detail, or even if you want to more privately, we can go through this template. Let's go back. No, I'm not done yet.
Okay.
Let's go further a little bit. We can even extend a little bit this first part so I can finish. And then we come back, we break a little bit later, Jason. What do you think? At least I finished this part.
I think that's a good idea. Please finish yours, and then we can just go into the discussion later. Yeah.
Okay, so this is the ISTI template. And I'm sorry, today I went to swim in the lake here in Brasilia, and every day that I swim, I have an allergy reaction. Okay, and for those of you who go to CCPR, know this discussion about changing the IESTI equation. I'm sure even those who haven't been CCPR have heard since many, many years now the discussion about the possibility of changing that equation. That starts from that discussion, that concern about the equation and how conservative was the equation. Is the equation protective enough for the consumers the way it is? So this discussion has been going on as far as I remember 2008, 2009. And then finally, there was some discussions in the meeting, but finally it was set up EFSA workshop, which was co-sponsored by WHA and FAO. I was part of that, I participated in that workshop, was just before the GMPR meeting started in September 2015. And actually the EFSA had already a proposal to bring it to the workshop. And they proposed, as they do until today, to replace in the equation the STMR NHR with the MRL. So if you see here, we have one case where we use STMR, or the other case we use HR. The proposal by EFSA, which was discussed at that meeting, was to replace the STMR NHR with the MRL, to remove the unit weight from the equation. So basically, we would have one single equation, because what differentiates those equations is basically the unit weight. If you replace everybody by a maximum residue level here, and if you remove the unit weight, you only have one case, the large portion times the MRL divided by the benchmark dose. And one thing that they also suggested, which I think is very reasonable, is because nowadays the consumption, the large portion you have here, is the large portion per person. And the country provides a single body weight for the whole country. This year, when I provide the data to Tringy, to WHO, I really provide the large portion of each crop and the body weight of the population which consumes that crop. Because later on, if this equation is changed for large portion divided by the body weight, that means the body weight is related to the people who actually consume that crop and provide the large portion for that crop. So that was also suggested. Currently, the data that we have from those countries does not allow to relate the large portion with the exact body weight. So the body weight is related to the body weight of the country, not related to the large portion of that country. So this discussion has been going on. We actually we had that meeting just before the 2015 GMPR. And then in the GMPR of that meeting, we discussed the outcomes of that meeting, but didn't go forward too much. I think it was in later meetings, we made a statement in the report that we still think that the equation was reasonable and is protective to consumers. And in 2016, and actually here in 2015, we proposed, GMPR proposed that the CCPR would set a group, yes, because it's basically, if CCPR really thinks that we have to move to a very conservative approach, we may consider to move, yeah, because coming from a management decision. So we recommend that the CCPR establish a CCPR working group. So I know that this working group would work sometimes, not electronic. I'm not sure, maybe Eduardo can clarify on that, because last time I went to CCPR, I think it was 2009. And this working group, what I know that lately that it's a working group. First, it was chaired by the Netherlands, and the latest year was chaired by Brazil, with some other Latin American countries. I don't know, there is another country which is chairing this group. And in this year report, in the 2021 CCPR report, there is a table where they spell out the advantage and challenges and the impact of changing. In general terms, actually, it doesn't, because they did not have enough data to really, because the objective, okay, at first CCPR was very reluctant in changing the equation, because it is until today, because what would be the impact on the MRL setting? You're going to see that the way we do it today, it will impact the MRL setting. If we change the numbers here, there will be more crops which will show a health concern, and less MRLs will be established by the codex. So you can imagine that countries are concerned about changing this equation. And in 2019 was already presented at GMPR a draft of this paper by Emily, who, using probabilistic modeling, evaluated actually compared the use of SMR and HRs and the use of MRLs and the impact of using MRLs in the equation. What they concluded in the paper was that the MRLs recommended by the GMPR using the current equations, that is STMR and HRs, give an adequate level of protections for consumers. This year, there is one general item in the report, in the summary report of this year's GMPR, with the table the recommendation table and the general items. And one of the items, go back to the STR equation, because in the report from CCPR in May, April, there was a request for GMPR to really say something about it again, because we've said many times, and that is basically the conclusion of the GMPR this year. The modification of the equation discussed at 2015 workshop are not expected to change the conclusions of the risk assessment in terms of consumer protection, but introduce an additional degree of conservatives based on the benchmark analysis. So there was some analysis done by Emily Crepe, that's her name, which is in this paper, which was published in Food Control Journal, in the journal Food Control this year. And actually the final conclusion was that, when I read it, is that there is no need to change the equations because the MRL set based on this risk assessment are enough for consumer protection. And if you change, we are just adding more conservativeness to the estimation, and we are not gaining anything. And the whole issue that Europe raised, I don't know if some of you has an issue, is that as in the equation, you are talking crop by crop, they need, that's the communication issue. You need to communicate that an MRL, how the dilemma is how you would communicate that an MRL is safe if you use another number to assess that safety. So that's the whole issue, how to communicate that to the public, that here to assess the safety, you are not using the MRL itself, but you use another value. The fact is, when you use monitoring data, you all know here in Brazil, that you only detect 50% of the residues in all samples. About 50%, this is in Brazil, everywhere in the world. Half of the samples that you analyze in monitoring programs in Europe, in US, in Brazil, in every other countries, don't contain any residue. In real life, you would not have any problem. Here we have conducted many studies using probabilistic approach, and the outcome is always there is no health concern. Okay, and finally, how the dietary risk assessment for pesticide impact the MRL set? That's the questions that most of you had since the beginning. As I mentioned before yesterday, very rarely we have an intake concern for chronic exposure. The last that I saw was in 2016, and the compound was actually not reevaluated, but additional crops were added. Additional MRLs were estimated in 2019, but this conclusion was already reached in 2016. Although this figure here is from the 2019 report. And for this compound, fluazifop P butter, there was an exceedance of the ADI. Remember that we do the estimation for the 17 clusters. And there was an exceedance of 160% of the ADI for cluster 16. Who is cluster 16? If you remember the cluster figure there are, in the whole Africa, 2 blue spots. There are 3 countries in the cluster 16, Gabon, Rwanda, and Uganda. 2 countries actually in the East Africa, and 1 country in West Africa. In these countries which make part of cluster 16, there was an exceedance of 160% of the AGI. Okay, chapter 4 of the report contains the summary of the dietary risk assessment conducted by the meeting that year. And in that Annex 3 of the GMPR report, you have the template that was generated. You have the table that was generated by the template. And here I show you the template for that compound, fluazifop P butyl. Here the template, I'm just showing the template from cluster 13 to cluster 17 because an exceedance was in cluster 16. So this is the first part of the template. Many crops, this pesticide has registration for many crops. Here we don't see any exceedance actually. And here, no, the exceedance is for total diet. Forget about what I've said. Here's just the intake, specific intake for each crop, but actually for chronic, you have to add them up. So this is the second page of the chronic exposure. You see many crops, but for chronic, as you said, you have to add them up to estimate the total intake. So for each cluster, you have a total intake here. Let's look at cluster 16, which is the one who gave an exceedance, 3 countries in Africa. The total intake in microgram per person is 384. Body weight of 60 kilos. ADI per person, this ADI here is 0.004 is per body weight. If you multiply that by 60, you get an ADI per person, and then you compare this intake per person by the ADI per person and reach 160.2, which was rounded to 160% of the ADI. And who is the intake of which crop is responsible for this high percent of the ADI? Is sweet potato. If you look here in sweet potato, the total intake is 384, but the sweet potato itself alone contributed to almost 60% of the total intake. The total intake was 384, but the intake only by consumption of sweet potato was 221. So if you just eliminate sweet potato from there, there is no intake problem anymore. So the conclusion was that the GMPR still recommends an MRL of 2 milligrams per kilogram for sweet potato. Still does that. There is no alternative gap, so we just go ahead and recommend. But our recommendation was not accepted by CCPR, and there was no Codex MRL for sweet potato. It doesn't affect the Codex MRL for all the other crops registered for this compound, but it did affect the crop that actually drove the total intake. So that's how the chronic intake affect the final recommendation of the GMPR. And what about the acute intake? The table of the acute intake is very rare that in 1 year there is no exceedance for one crop pesticide combination for the acute exposure. This table was taken also from the 2019 report, and you see here that fluazifop P butyl has a chronic intake problem for cluster G, but there is no acute problem, because we also don't have any large portion data coming from Africa. Maybe if you had a large portion data coming from Africa with a large portion of sweet potato, maybe we could have an exceedance here, but we don't have data from Africa for acute exposure. But we have many exposure exceedance, see here, and most, if not all of them, for children. So for PG flumethofen, an exceedance for lettuce, an exceedance for endive, an exceedance for spinach. For children in the Netherlands, for in China, the Netherlands, for toddler in Belgium, for toddler in the Netherlands, and you have also exceedance for this compound here, p-flubromide for apples, coming from high consumption by children in Australia, in China, and in Ireland. For this other compound as well, for tomatoes and for aubergine, and that's it. And in the report, in the chapter 4 report, we indicate that as no alternative gap were available to the meeting, to estimate lower values for those compounds, for bifenthrin. Oh, there is an exceedance for bifenthrin here, strawberry for toddlers. For bifenthrin, all those compounds which actually had an exceedance for some crops, no refinement of the acute dietary risk assessment was possible. And the meeting recognized that this estimation may be refined if new data come. So the company who needs those, because what's going to happen is that the maximum residue level is recommended by the GMPR, but they are not adopted by the Codex Alimentarius for those crop pesticide combination. So the company may say, oops, there is an alternative gap somewhere in the world, which gives rise to a lower HR. So we're going to submit it to GMPR, and GMPR will use an alternative gap and will make a lower MRL recommendation, which probably won't give any exceedance of the acute reference dose. And in some case, here it's all fruits and vegetables. In some case, there is an exceedance due to, for example, all those vegetables, actually, they are edible peel and they can be eaten raw. So there is no refinement coming from processing studies in this case, only with alternative gap. But for example, let's see if there was an exceedance due to consumption of orange and we did not have residues in the pulp to establish an HR in the pulp. So maybe that would be a way around that the company would provide the data in the pulp. But in this case, no, only an alternative gap would solve that problem. And in the Annex 4 of the report is basically, you can see the template, the resulted template as I showed you before, where it showed the exceedance here for children. Yeah, for PG flumethylfen, for lettuce, endive, and spinach. And that's the kind of final slide here. What we write in the dietary intake section of the report. If there is no intake problem, we just say the meeting concluded that the long or short term, there is an entry for each case when there is an acute reference dose for the acute, for the compound X resulting from the uses that have been considered by the GMPR is unlikely to present a public health concern. If there is an intake, an exceedance, again, you could refine it. Everything that is written here, I have already said. And the conclusion is that for long-term, chronic, the meeting concluded that the long-term dietary intake exposure to residues of X from the uses considered by the GMPR may present a public health concern. Short-term, and then the intakes from the were less of compound X, were less than 100% of the acute reference dose, except for those crops. In the case of that compound there was for lettuce, spinach, and endive. The meeting concluded that the acute dietary exposure to residues of compound X from the use considered by the present meeting in lettuce, endive, and spinach may present a public health concern. It's important really to emphasize the may here. You cannot say, and we use words like unlikely and may. Why? Because the dietary risk assessment process has many uncertainties. So you cannot say for sure the 100% ADI or the acute reference dose is not a solid barrier. If you pass, you will develop adverse effect. If you don't pass, you will not develop an adverse effect, because you have an ADI or an acute reference dose, but you have a borders around it. Yes, a boundary. I think that's the boundary. That's the word, the correct word, around it. So you have a lot of uncertainty. You have uncertainty in the field trial. You have uncertainty in the analytical method. You have uncertainty in the lab, toxicological lab study. You have uncertainty everywhere. You have a large uncertainty in the consumption information figure. So you have a lot of uncertainties. So you can never say for sure it will cause or it will not cause. So that's kind of you see slight different statement from one expert from the other, from 1 year from the other, but basically that's it. Okay. So that's it. Actually, here's some pictures from the GMPR. This is Ursula, my friend, from Germany. She left GMPR already. Michael, who is the current chair. And here you see Christian from BFR from Germany, Dougal from Australia, Min Yang from South Korea. And here, 2 pictures from my laboratory, just to illustrate. It's a very nice laboratory. You are all welcome to visit me if you come to Brazil. Okay, maybe we should then break for lunch, and then we come back at 1 o'clock in 10 minutes, maybe at 1 o'clock.
That would be 20 minutes, I believe. Right now it's 10:45. Let's see. Maybe Adriana or Veronica, what do you have for advice at this time? Should we take a longer break and resume in 15 minutes then? That would put us at, I think, 11 Eastern.
Yes, 11 o'clock. I think it's okay if we go back at 11 o'clock, and then we're going to be, if it's necessary, 1 hour of discussion.
Okay,
Is that okay,
15 minutos.
Adriana?
Okay,
15 minutos.
that would be fine then. Okay, so we'll resume back in 15 minutes.
I think Eduardo raised his hand. If it's a question, Eduardo, you can ask after the break.
Okay, thank you. Briefly, it's just a comment about the template of the ISTI.
Can we talk about it after the break, Eduardo?
Yeah, of course.
Okay.
Of course. Okay.
We talk about it after the break. Okay.
Okay.
See you.
Thank you.
See you all
See
in
you.
50 minutes. Bye-bye.
Hi. So welcome back. I think that it's time for us to get started with a question and answer session. And if we can, Eduardo, if you are still there, I think we could start off with your question right off, and then I think we'll move into the chat box after that. Thanks, Eduardo. to remember to do that. So Veronica, maybe you could let me know if we would like to take that group photo now before we have any closing remarks.
She said she was having trouble and she will go out and come in again. Oh, she's
Okay.
back.
Ya estoy de vuelta.
Veronica.
Me estaban hablando.
Did you hear my question, Veronica? If we would like to have the group photo now, and I apologize to you for messing that up during break.
Yes.
Y perfecto. Y le invitamos a todos los que puedan y gusten encender sus cámaras. Ya tengo aquí, tengo que hacer 3 porque me salen en 3 grupos. Estoy con el primer grupo, me faltan unos 3, 2, 1. Ya voy a tomar la primera. Ok. Están muy guapos hoy, salieron bien. A ver. Un momento. Ahora sí. Ok, tenemos la primera. Vamos con la segunda, segundo grupo. El segundo grupo está un poquito más tímido. Tenemos 50-50. Pero vamos con este. Ok. Vamos con la segunda. Y ya estamos con el tercer grupo. El tercer grupo es el grupo de los tímidos porque ninguno encendió la cámara, pero vamos a tomar aunque sea los nombres para recordarlos que estuvieron acá presentes. Listo, muchísimas gracias. Ya tenemos las fotografías del evento. Les agradecemos mucho.
Thank you, Veronica. So next, we would like to have some closing remarks. And I think there first is going to be a presentation and some remarks by Dirk Drost from the Minor Use Foundation. So if we can pull up his presentation for his closing.
Thank you very much, Jason. It's been a pleasure to participate in the sessions this week, to see the energy and enthusiasm by Dr. Calderas and also by you as participants. Let's go to the second slide, please. We've heard a lot this week about the data packages and how they are prepared. And I just want to remind you that the data packages are ultimately submitted to the JMPR for evaluation. And the Minor Use Foundation is definitely involved in generating data. Project teams around the world that eventually are submitted to JMPR for evaluation and eventually for the creation of new MRLs. I mean, and we've heard clearly this week how important it is for this process to run smoothly, and that we have strong and efficient JMPR to conduct these evaluations. And I think you've all gotten a great introduction to that this week. Next slide. I'm going to just summarize briefly some of the projects that have been supported in Latin America and completed. These were supported by the STDF grant: avocado with spinetoram, pineapple with pyriproxyfen, and banana with pyriproxyfen. And the latter one, banana with pyriproxyfen, the Codex MRL is pending. Next slide, please. Currently, we have some ongoing work in Latin America, ongoing projects, a banana, a spinetoram. We have a pineapple with spinetoram, a papaya with flupiram and trifloxystrobin, cacao with oxythiopiperine, a passion fruit with sulfoxaflor, and coffee with indoxacarb. These projects are being run by the Minor Use Foundation with local project teams in Latin America, led by study directors and study teams. And I want to thank each of them and each of you for the current projects that we are underway with. Next slide. Now for the future. It's all about the future, and these are some of the studies that we will be initiating. Mango with picoxystrobin, pitaya and spinetoram, eggplant. We hope to conduct some work with eggplant, tomato with Tuta absoluta, banana, avocado with ethoboxam and metalaxyl, and then pineapple with ethoboxam. I mean, there are other priorities that are constantly being identified, but these are some of the studies and the numbers of trials that will be conducted and will include study locations in Latin America. And once again, I'm grateful and thankful for the teams that are coming together to support this work, and for the individuals, some of whom are participating in this seminar this week, for your dedication and your enthusiasm about the work that will ultimately benefit not only growers in Latin America, but also growers around the world. Next slide. Let's talk a bit about the future. You've gotten introduced to the Minor Use Foundation's website, and it's available in 3 languages, Spanish, French, and English. Some of you are familiar with the Global Minor Use Priority Setting Workshop that was sponsored by the foundation last September. You are part of the partners and colleagues in Latin America that we are working with to conduct training and capacity building in the region. And I just want to highlight that, you know, pending the ability to manage travel and the opening of global travel, the next Global Minor Use Summit will probably be late 2022 or early 2023. But while that seems a long ways off, we have something in the works for early in 2022 in Latin America and the Caribbean. We, as a foundation, intend to host a minor use priority setting meeting. The time is pending. We'll decide that in cooperation with the foundation and local partners, but we wanted to just make you aware of that today, that's something that's coming in early 2022, and you'll get plenty of information and lead time for that important priority setting meeting. Next slide. And with that, I'd like to acknowledge this, the support provided by the STDF, by IR4, by FAO, and by USDA in the creation of the Minor Use Foundation 2.5 years ago. I'd like to extend my strong thanks to IICA and to the project work teams in your countries that have carried out pesticide residue studies with great care and with great success. And finally, I'd like to state that the Minor Use Foundation is honored to host this workshop, which provides a critical link between yourselves and the JMPR. So thank you on behalf of the foundation for your participation and this week.
Thank you, Dirk, very much.
And then the final slide, which you'll have access to, has my contact information. And of course, you're welcome to contact me at any time if you should need to. Thank you very much, Jason. It's back over to you.
Okay, thank you, Dirk. I really appreciate that. Next, we have Fred Johnston from the U.S. Department of Agriculture's Foreign Agricultural Service. I hope he is going to be able to turn his camera on, and he is here. Okay, I'm going to hand it over to you, Fred.
Hey, good morning, everyone. I come to you today from USDA's Foreign Agricultural Service in a cold and windy Washington, D.C. It's kind of breezy out there. I'm Fred Johnston. I'm the director of the Multilateral Programs Branch in the Trade and Regulatory Capacity Building Division. I'd like to start by thanking the sponsors of this event, the representatives from JMPR, Madam Yang and Eloisa Dutra, and the Minor Use Foundation, Veronica Picado, Jason Sandal, and Adriana Castaneda. I'd also like to thank our presenters and, of course, all of you for participating in this workshop. We all know the importance of Codex Alimentarius as the international standard-setting body for food safety. USDA is committed to supporting Codex in the region through a variety of programs. We believe it is important that we work together to continue to support it by establishing new tolerances that help to provide farmers with important crop protection tools while also facilitating trade. We need collaboration from all countries. USDA collaborates with the Minor Use Foundation through our joint residue program that works with international study teams to submit data packages to Codex. We're partnering with the National University of Columbia to further support study teams in the region on how to conduct residue trials according to good laboratory practices. This workshop is important because it helps to familiarize countries with the processes required in the FAO 224 manual to avoid the rejection of data packages and create an environment in which all countries are well-versed in Codex requirements. So I won't take any more of your time. Thanks for participating in this and enjoy the rest of your day. Thank you.
Thank you very much, Fred. I have a couple housekeeping items that I would like to mention before I close and or ask anybody else. First of all, if everybody could provide their full names in the chat box so that we know how to address the certificates that will be provided later. We'd like to have the full names so we get the names correct on the certificates. So if everybody can do that in the chat box at some point, we'd appreciate that. Next, I just open up. If anybody has any other closing statements, you're welcome to join in. But from myself, I would like to again thank Dr. Caldas. Thank you, Eloisa, for a fantastic workshop and presentation. And I really hope that we're able to do this again in maybe other regions. This is really valuable. And I think that, from the participation we saw over the last 5 days, we still have almost, I think, the same number of people today than when we started. That means we have a very high retention rate. It means you did a great job to keep everybody's attention. So thank you very much, Eloisa. Also, FAO, Madam Yang, the JMPR Secretariat for providing the materials and the resources to help us do this kind of a workshop. The Standard and Trade Development Facility, again, they've been an instrumental partner in getting these programs together with us in the past. Minor Use Foundation, thank you, Dirk, and other board members for your support. USDA, Fred and his team, who have provided, again, resources and the will to help us with this, and IECA also. And finally, I'd like to thank the interpreters. They did a fantastic job keeping up with all the technical language that Eloisa was throwing at them. They did a great job of interpreting the questions that were provided for them. I know this is very difficult. So thank you to the interpreters for such a great job. And finally, I'd like to thank Veronica and Adriana, my partners in this in organizing this workshop. I do see that Veronica has her hand up. So with that, I'm going to pass over the final words to Veronica.
Muchas gracias, Jason. Nada más quería agradecerles a todos su buena participación, lo fuerte y bueno y rico, estoy usando una expresión muy latina, que fue la sección de preguntas, y para mencionarles que tan pronto como sea posible les estaremos compartiendo el material del taller, las presentaciones y todos los demás complementos que envíe la doctora Eloisa, y además una pequeña encuesta para evaluar el taller y que nos retroalimenten en qué temas les gustaría tener nuevos eventos. Que pasen un muy bonito día. De paso a Jason.
Okay, with that, I'd like to close the workshop. Again, thank you, everybody.
Can I just say a few words, Jason?
Oh, yes, please, Eloise. I'm glad that yes.
I just want to thank you, the organizing, for inviting me. I'm a professor, so I like teaching. So I hope I could really do my job well. And I hope you will enjoy it. And I feel free to contact me by my email, which will be in the presentation. My email is very easy. It's just my name, eloisa@unb.br. So just ask me any question if you want some additional details about any issue that we've discussed that during the week. Just feel free to contact me. I wish you a good weekend, a good rest. It was a very rich week for me with many, many questions. It was great. Thank you and bye-bye, everyone.
Thank you all.
Ciao.
Ciao, ciao.
Thanks a lot. Bye bye.
Ciao.